So now that we've seen this formula for how to do the line integral of a vector field, let's look at an example. So let's evaluate the line integral of f dr, where f of xyz is xi plus yzj plus zxk. And c, the curve, is given by x of t is t, y of t is t squared, and z of t is t cubed, where t goes from 0 to 1. So just to write that in a different way then, we up top talked about that as being this curve R. So if we do write that then in this component form rather than parametric equations, we could have my x component is t, and then y is t squared, and z is t cubed. Notice up top, we're going to need the derivative of that. So let's go ahead and find r prime of t. So remember, to do that derivative, we just take them component-wise with respect to t. So we're going to have the derivative of t is 1, of t squared is 2t, and of t cubed is 3t squared. So then when I do this integral over c of f dr, we're going to really integrate over the range of t, which is 0 to 1, and then we're going to take f. Remember, we're going to plug in to these components here. We're going to plug in, say, the x of t, the y of t, and the z of t in for x, y, and z. So if I write it in terms of those x, y, and z values first, it would be x, comma, y, z, comma, zx. And we're going to dot that with r prime, which is 1, 2t, and 3t squared. And we're going to do this dt. But I don't want the x, y, and z's in there. I want it to all be in terms of t. So notice x, we plug x in, and we're going to have x is t. We're going to plug yz in, so yz is t squared times t cubed, which would be t to the 5th. And then we're going to have zx, which would be t cubed times t, which will be t to the 4th. And then we're going to take the dot product of that with 1, 2t, and 3t squared. So the dot product, we're going to multiply component-wise and add those together. So we'll have t times 1 plus 2t times t to the 5th is 2t to the 6th. And then 3t squared times t to the 4th will be plus 3t to the 6th as well. So then we've got the integral 0 to 1 of t plus, we've got 2t to the 6th and 3t to the 6th. So 5t to the 6th dt. So then taking the integral, the power on t will go up to a 2, and it'll get divided by that new power. So we'll get t squared over 2 plus t to the, we'll go up to the power of 7. And then we had the 5 in front, and we'll divide that new one by a 7. And we're evaluating all of this from 0 to 1. So plugging in 1, we see a half plus 5/7, and then we would subtract off plugging in 0, which is just 0. And then if we do want to combine those together, we could get common denominators, so it would be a 14. So we could have like 14 over 7 plus multiply the other one by 2, so 10 over 14. So really we have over here is 14 over, I'm just writing it wrong altogether. Let's do the first one again. 1/2 would be 7 over 14. There we go. So then 7 plus 10 is going to be 17 over 14 for our final evaluation of that line integral.